What if your agent ignores a perfectly good tool it could use? Welcome to AI Agents in Depth, Episode 4, Tools and MCP. You'll design, register, and test MCP-compatible tools without touching the agent loop. Your workspace already has 2 tools, word count and retrieve. You don't need Episode 3. Both are pre-built and waiting. Today, the design rules that make them work. Let's anchor on the book first. This opens Chapter 4 as an image, right inside VS Code's editor. Chapter 4, Tools and MCP. From Boji Lai's book. Section 4.2 names 3 failures from bad descriptions. Skipped calls, wrong timing, bad types. That's today's target. Now swap to the anatomy diagram. Excalidraw is VS Code's drawing tool. This diagram is pre-drawn and waiting. Screen changed, diagram, not a photo. 3 rows, name, description, parameters. Name, what the model types back. Description, the only line it reads. Parameters, typed for valid JSON. Here's the twist. The model can't see your Python function. It only reads the description string. Your function's type annotation protects your code, but the model never sees it. Agent, Py has 2 pre-built tools, word count and retrieve. Your turn, press Ctrl-P, type agent.py, and hit enter. Find tool descriptions near the top. It's a plain string, what the model reads. Both tools, verb name, typed parameter, clear return. That's the pattern. Agent, Py is already open. A well-designed tool needs a verb name and a typed parameter. Let's write one. Get weather, a verb, not a noun. 1 parameter, city, a string. Section 4. 2. Minimum sufficient parameters, each extra one costs the model a reasoning decision. Now the description. This is where most people get it wrong. Watch closely. Process city input is a developer comment, not a model trigger. The typed parameter in that string guides the model's JSON call. A missing type causes malformed args. 1 line wires the handler into the tool's registry, and placement matters. That's direct registration. 1 assignment, outside run agent. Never inside the loop. The loop runs up to 10 iterations per call. Tools added mid-run break threading. Go ahead, try it. Run this and confirm. Get weather is in the tool's registry. Three tools in the registry. Word count, retrieve, get weather. 0 changes to the agent loop. Next milestone, we'll add a 4th tool, but through the MCP adapter, not direct assignment. You just wired get weather in by hand. The MCP adapter does that same job in 1 call, for any tool, from any source. Let's prove it with a brand new tool. Write a brand new stock price tool, then it's MCP spec. Same 4 fields from the diagram. Name, description, input schema. Think of input schema as a form definition. Ticker is text, not a number. JSON schema is that shape language. The model reads it to know what to send. Now the payoff. One tiny adapter that turns any MCP spec into a registered tool. Six lines. It pulls the name and description, builds a typed parameter string, appends it to the descriptions, and drops the handler into the registry, never touching the loop. Before we call it, let's confirm Python can import what you just wrote. No errors. Adapter ready, no errors. Run this before wiring any new function into a live system. Now it's safe to call it. MCP normally talks to a server over the network. Here we register a local handler, offline, identical every take. One call, and the stock tool joins the registry, beside word count and retrieve. Composition happened at registration, not at call time. Swap one URL, and it's a real server. Your turn. Prove the adapter worked. Check whether the stock tool is really in the registry now. True. A tool you never touched the loop to add. A local stub, or a real MCP server would land here identically. Next, proving the agent calls it. Every tool call goes through one function. You'll want to read it before testing. See the function called parse action. It strips the prefix, finds the tool name before the first paren, parses the JSON args, then fires a registry lookup by name. Add a key to the registry. That's the entire registration. The loop never changes. Open the test file. You'll add two things below the existing tests. A stub is a fake replacement that always returns the same scripted value. No real model, no network, no cost. That makes tests offline, free, and identical every run. You'll write one stub function, then one test that calls it. This stub has exactly two paths. Watch for the two return lines as they appear. The bottom return fires on turn 1. No tool result yet, so it sends the get weather action with City London. The top return fires on turn 2. The tool already ran, so it wraps that result as the final answer. Two scripted turns. The loop sees both identically every run. Two asserts. Both the city name and the return phrase must appear. Both asserts matter. London proves dispatch hit the right city. Sunny proves the weather handler actually ran. Not just test passes, exact parameter fidelity. Your turn. Run all 5 tests right now. Five green dots. The dispatcher routed the weather tool through the same registry lookup as word count. No decorator, no rewiring. The registry grew. The loop didn't change. You designed a well-typed tool schema, name, model-facing description, typed parameters, and saw why the description is the model's only contract. You built an MCP adapter and proved its composability by registering a brand new tool. Get stock price without touching the agent loop. Green tests confirmed correct dispatch through the adapter. Pause here and try this. Write a tool called summarize text with a text parameter typed as a string. Add its MCP spec dict. Call Register MCP tool with a stub handler returning summary, plus the input text, and write a pytest asserting the agent's answer contains summary. Quick check. What does the model read to decide which tool to call? The tool description's string in the system prompt, not the Python function signature. Second question. After Register MCP tool runs, do you need to change parse action? No, parse action does a plain dict lookup by name. The tool lands in the tool's registry the instant the adapter writes it in. Next up, Episode 5, the coding agent. Follow so you don't miss it.